recorded.
Can everybody hear me? Please answer in the chat. Great. Do you see the slides? Okay, wonderful. Then let's begin. Welcome to our next event in the series of Wolfram Technology webinar. The topic for this seminar is Mathematica Online and Wolfram Cloud technologies. Before we go to the subject of this talk, let me just introduce ourselves. The company I work for is called Unisoftware Plus. It's a very small company located in the small town of Berg in Upper Austria. We are around 30 employees, and most of these employees are either theoretical physicists, software engineers, and data scientists. So we are a very technical company in the field of computing. One of our main business areas is being Wolfram technology reseller. And as a reseller, we serve mainly the German-speaking parts of Europe, where we have many site licenses. For example, we have all the Austrian universities under contract. And in Germany, our largest contract is with Fraunhofer Gesellschaft Germany. What kind of services do we provide to our customers? We provide license and installation support. It means we guide our customers through the whole process of ordering Mathematica or a different Wolfram product until this product runs on the customer's machine. And a large business area is also doing technical support in using Wolfram Language and Wolfram products. And this is very interesting because this is something I do very often, and it's amazing what you learn about the system just by doing technical support for it. But of course, we also have other business areas. One very important business area is doing big data science. Here we are heavily invested in the Hadoop technology stack. Of course, we also use Mathematica on the back end for doing data science analysis of the data installing these big data services. Another area is industrial mathematics, where we do classical simulation and classical mathematical modeling. And we also have our own Unrisk product line for financial mathematics, which is called Unrisk. And Unrisk is, for example, available as an extension to Mathematica. Let's now discuss the topic of this talk. The agenda for this talk is what is Mathematica Online? What is the Wolfram Cloud? Let's just clarify these terms, which create some confusions among users. Let's just clarify how can you use Wolfram technologies from your internet browser? How can I use Wolfram Cloud technologies from my desktop Mathematica installation? How do I access data in the Wolfram Cloud? How do I run computations in the Wolfram Cloud? How can I deploy my Wolfram language code or my project or my notebook in the Wolfram Cloud so that other users can consume this notebook or this data without actually being Wolfram users? And finally, we will talk what are the upsides and downsides of the Wolfram Cloud. Let's just clarify the term Wolfram Cloud and Mathematica Online. Actually, both refer to the same technical system. When Wolfram started development, the Wolfram Cloud, it was initially named Mathematica Online, but nowadays Wolfram refers to this product as Wolfram Cloud, and this is the term that I'm going to use for the rest of this presentation. What is the cloud, or the Wolfram Cloud? The Wolfram Cloud is just an external system which allows for storing data and for running external computations. You can access this external system either through your Mathematica front end, which is installed on your local machine, or you can use your browser, which usually is pre-installed on your operating system, to access the data and the computations which are available in the cloud. The cloud stores all data in a hierarchical file system, which supports both files and directories. And these files can be, for example, Mathematica notebooks, but they can also be all files in all file formats, which are in some way readable from the Wolfram language code. Like, for example, image documents or HTML documents, text documents, multimedia files, or even database files can be uploaded to the cloud. But the cloud can also store generic Mathematica expressions, like, for example, mathematical lists, Mathematica associations, or Mathematica datasets. And you can also run computations in the cloud. And you do this by actually allocating a cloud kernel in the cloud. And this cloud kernel will then run some computation for you and return the results back to you, the Mathematica frontend or your browser. Another important aspect of the Wolfram Cloud is the separation of two different activities, which is called development and deployment, or authoring and publishing. The following graphics tries to make this distinction clear. When we talk about the cloud, there's actually a private area in the cloud, which is depicted by this dotted line here on the left side, and there's a public area in the cloud. In this private area, as an author or as a Mathematica developer, you use your Mathematica desktop or your browser to upload data to the cloud, to upload code to the cloud. And there's a set of functions available in the Wolfram language, like, for example, cloud put and cloud get, to do that. And in order to be able to access the cloud, you need a subscription plan. And these subscription plans are available in different stages. On one end, we have, for example, a free plan, which is completely free, and on the other side, we have more expensive plans. And these plans describe, for example, how much memory you will be able to use on the cloud, or how much computational resources will be available to you in the cloud. On the public side of the cloud is when you want to share Mathematica notebooks, or share, for example, and manipulate code that you have written with other users. You usually have to make these developments available to other users through a process called deployment, and therefore there exists the function cloud deploy. This cloud deploy makes the developments available in the public cloud, and here all these developments can then be accessed from a third party, which this third party may be an arbitrary internet user, which has, for example, never used Wolfram technologies before. And here, Wolfram has applied a pay-per-use model, where cloud credits are used each time that when a third party consumes one of your deployed resources. We will learn about cloud credits on the next slide. And what can you actually do in the cloud? You can share Mathematica notebooks. You can share interactive content, like, for example, Mathematica manipulates. You can share API functions, like, for example, HTTP REST as HTTP REST web service. And you can also run scheduled tasks with Wolfram language code. Like, for example, if you have a financial computation which want to run on a daily basis, you can run this as a scheduled task, and this scheduled task, for example, can then produce a report which you can download from the cloud then. Let's just talk about cloud credits for a moment. Wolfram Cloud credits are the currency of the Wolfram Cloud. These cloud credits are consumed by deployed Mathematica code when this code is used by a third party. And computations that you run while you are developing your project. That means when you are completely doing when you are completely restricted to your private area of the cloud, do not consume any cloud credits. Every Wolfram Cloud subscription includes a supply of 50,000 credits, and these credits work similar to, for example, a subscription plan that you have on your mobile phone with a certain allowance on gigabytes. That means at the end of the month, these 50,000 credits will be renewed, and the credits that you did not use simply expire at the end of the month. But you also have the possibility to purchase additional cloud credits if these 50,000 credits are not enough, and these purchase cloud credits, of course, never expire. If you want to learn more about cloud credits, there's a very nice page on the Wolfram home website where you can learn about cloud credits. For example, here you have a detailed overview about how many credits are used for doing certain tasks. Like, for example, interacting with dynamic deployed notebooks will cost you 1 credit for each 100 milliseconds of computation that the user does. From your notebook, you can actually inspect the available cloud credits by evaluating the variable $cloud credits available. And these cloud credits are tied to your cloud user ID, which here is, for example, my email address. After all this talk now, let's just have a look at the real thing. Let me go to the Wolfram Cloud website. Here in the Wolfram Cloud, this is the homepage of the Wolfram Cloud. And actually, you can either sign here up for a free basic plan, but I already have my account, so I'm using the sign in here. I'm using my email address as a sign in account. Then I have to enter my password. And when I'm done, I'm presented with my homepage at the Wolfram Cloud. You see here, I can either now immediately create a new notebook in my browser, or I can browse my existing files. And if you look at the menu bar here you see the actual plan that you have subscribed to, which is a sales partner plan for us. You have access to the whole Mathematica documentation here, which is very, very nice. You have access to all the cloud files that are stored in your Wolfram Cloud account as a list. And you also have a very nice, for example, search feature here, where you can look up things in the documentation. Let's look up the function manipulate. And here, this takes me directly to the documentation of this function. I also can inspect my user account here. For example, the usage dashboard brings me to another site where I can actually see how many deployed resources I have, how many usage, and again the usage statistics about these different deployed resources. I'm also shown the amount of credits available. And if I close this tab again here, I'm returning to the Wolfram Mathematica homepage. And now let's just create a new notebook. Every time you create a new notebook, a new tab is opened in your browser, which represents this new notebook. Here I have a small entry field where I can simply name my notebook. Let's just say this is the demo notebook. And today we have in 2021, 1019. And this is the name that will be used. And one interesting thing about the cloud is that in the cloud, there is no saving. That means everything you do is saved automatically, which is very good, because there is no risk of losing something, as you might have with the regular desktop Mathematica, which may occasionally crash. And here you never lose any content that you have entered on your notebook. The notebook works similar to the desktop front end. Let's just start with a demo here. Notebook. And here I can, for example, using the format menu, I can now select this cell here and say this is actually the title of my notebook. One interesting aspect about the cloud is if I evaluate, for example, the version number, you see that this Wolfram Cloud is actually on the latest version of Mathematica. This is one advantage of the cloud, because Wolfram, each time there's a new version is released, it is immediately rolled out into the cloud, and there is no need for doing a manual installation. If you have ever installed Mathematica manually, you probably know that this is a very lengthy process where you have to download huge installation files, and the installation itself usually takes a long time. And the installed desktop application takes gigabytes on your hard drive. All these problems are avoided in the cloud. Of course, in the cloud, you can do all the regular things that you're used to as a Mathematica user. You can enter simple computations. You can, of course, work with unlimited precision. Like, for example, let's do a factorial from a number here. And thanks to the unlimited precision computation powers of Mathematica, it will return the correct result. Of course, Mathematica can also do symbolic computations. I can do an integrate, for example, of the, let's say, sine x function times x squared for x, and this will then be evaluated symbolically, and Mathematica, or in this case, the Wolfram Cloud, will return the correct result. Of course, the Wolfram language is a symbolic language which allows for the representation of any kind of data. For example, that we can use it to produce graphics. Like, for example, here I want a graphics with, let me say, give me a yellow disk. And if I evaluate this thing here, the output form will be actually the graphics that represents this Wolfram language code. And here, for example, I can then easily, on the right side here, I can, for example, do a nice copy of this thing and do a copy and then paste it, for example, in a different network, different desktop program, like, for example, a word processing application or something else. Of course, since it's a graphics, I can also scale it here using the sliders here. And of course, we can also do plots, as we are used to doing on the desktop. Let's just plot the log function, x with x going from, say, 0 to 100. And this will produce a nice CD plot, two-dimensional plot here, where I can also interact with this graphics by simply resizing the handle. I can also do 3D plots, plot 3D from a function. Let me just speed this up a little bit by pasting the command here. And this gives me a nice 3D representation of my graphics. And if I double click this graphics here, what I can do now, I can really rotate and inspect these graphics from all different sides, which is based on WebGL technologies built in your browser. Of course, I can also move from simply plotting, I can move to interactive graphics by using manipulates. Yeah, I want to do the same plot, but I want to change the wavelengths of this plotted 3D function by using a slider. And here I have a slider here where, and if I change the wavelengths here, you see that the graphics will then adapt to this setting of the parameter k. And again, I can double click here, rotate this graphics and regard it from different angles. And of course, this is also similar as you would expect to work it in the notebook frontend. But of course, there's more. I can import data into my Mathematica session on the cloud. For example, here I've prepared an image. And this image is an image of a cat. And where does this file actually come from? Here, let's go to the cloud files and inspect this. Here you see that the file is located here as cat.png. And I have uploaded this file before this demonstration here using the upload file interface, where you can simply upload files from your local file system to the cloud. And once you have this image in your Mathematica session, you can of course run different image manipulation code on this image. Like, for example, I can use image identify, the machine learning model for identifying images, which is built into the Mathematica language. Here, it actually has to download this machine learning model to the machine which runs my code here. And if once it's done, it runs an image identifier in the image, and you see the image is correctly identified as a cat. One interesting feature which has recently been added to the Wolfram Cloud is the ability to enter LaTeX code directly in your sessions. I simply have to press Ctrl+4, and this gives me a new text entry feed where, for example, can then enter directly LaTeX code. Alpha, let's check on lookup beta. And if I press the enter function now, then you see it's correctly rendered as an LaTeX expression. When I'm done with my notebook, I simply can close it here, and it's then available in my cloud files. And in my cloud files, you see here, if I simply click it here and double click it here, it will be reopened, and I can resume editing from the point where I stopped. Let me close it again here. And let's now go back to the Wolfram notebook front end. Of course, the Wolfram Cloud can also be used directly from your Wolfram notebook front end. The first feature is you have a possibility to load and save Mathematica notebooks. Here I can, for example, use the open from cloud command. This opens a file browser which goes to my cloud account and lists all the files which are stored there. And here, for example, you see there's this demo notebook which we just created, and I simply create open here, and it will then show a progress bar that it opens this notebook, and you see it's actually the same notebook that what we used in the browser a few minutes ago. And I can, for example, now here make some changes, like add an additional computation. Let's say, like, I just want to print the date. And if I press use the save command here now, you see that the file is actually now saved back to the cloud. It's not saved to the local file system; it's automatically saved to the cloud. So that means you could have a workflow which even when working with Mathematica on the desktop, you could have a workflow where you store all your notebooks in the cloud so that they are available from all your machines, regardless of the machine where you actually run your Mathematica notebook. Now let me close this notebook again. Of course, there are also it's also possible to interact with the kernel from with the cloud from the local Mathematica kernel. Here, Mathematica has always knows if it's connected to the cloud. Actually, I'm always keeping Mathematica fronted connected to the cloud, and this can be seen here. For example, in the help menu, here you see that I'm signed in as with my account here. And the Mathematica stores this account data, so that each time you launch Mathematica, it will immediately automatically connect to your cloud account. If I'm not connected to the cloud, I can use the command cloud connect to connect to the cloud. This will all print my cloud ID as a result. And two other important informations are the cloud base, which shows me the actual URL of the Wolfram Cloud that I'm connected to. This here, the cloud the URL you see here is actually the public cloud. But if I'm using a private cloud installed somewhere on a local server, this URL might be actually different. And cloud userd is the userd that I'm using that my actual cloud session is connected to. How do you access data in the Wolfram Cloud? For this purpose, the Wolfram language has added the concept of a cloud object. What is a cloud object? A cloud object is a handle to data stored in the cloud. For example, each object that exists in the cloud, for example, the cloud root directory, is actually wrapped in this cloud object symbol head. And I can inspect, for example, using the information command, I can get information about this cloud object. This shows me, for example, a UUID of this object. It shows me that it's a directory. It shows me the byte count that it uses. It shows me the information about when it was created and who created this. And importantly, it also shows the permissions. That means as a user, what can I do with this object? And I can read, write, and execute this directory. And in the cloud, there also exists a concept of a current directory similar to the desktop. And this cloud directory is the home directory of your cloud account. I can use the cloud objects command to enumerate all the files which are stored in my cloud, in my actual cloud directory. And you see I get back again different cloud objects. And these cloud objects can be used like regular mathematical expressions. For example, I can use the map function to run, for example, a file type on these cloud objects. And this will then tell me if these different files are actually directories or files. And cloud objects are central to working with the Wolfram Cloud. Of course, you may want to put mathematical expressions to the cloud. You can do this with cloud put and cloud get. Let's just, if I run the cloud object function without any arguments, Mathematica creates a handle to an empty object which is stored in the cloud. That means if I look at the file type of this object, it actually has none because it's just a hollow form of data. It doesn't exist yet. And if I return information, it says missing because although there's a handle, there is nothing in which this handle is associated to. Using cloud put, I can now, for example, put the list containing the three numbers 1 to 3 to the cloud. And this will then return the same URL that we created here. And if I look at the file type now, you see that it's now stored as a file. And this file, if we look at the information here, you see this is actually an application Wolfram expression file, which is rather small and simply contains the list 1, 2, 3. If I want to get back this object later, I only have to use the object handle to get back the data, and this will immediately return the list which is stored under that handle here. Here when we use the cloud object function here, it created a temporary URL which has a UUID here, but I can also create a named URL with a certain name, and if this can be passed as a string argument to the cloud object function. And here I get a much nicer URL. And if I can then put, for example, a string to this cloud object. And of course, these cloud objects are persistent. It means that even if I quit my Mathematica session, these cloud objects will be stored permanently in the cloud. How can I access data in the Wolfram Cloud? By data, I now mean more complex data, like, for example, images, multimedia files, text documents. And for this purpose, the Wolfram language has added the functions cloud export and cloud import. And these functions support all the import formats that Mathematica knows about. This is a list which gets larger with each release. Here we have different formats, like, for example, like structured data formats, like, for example, XML. And there's, of course, also JSON. We have different, for example, multimedia formats like MP4 and MP3. We have raw data formats like, for example, HDFS and HDF5. We have zip. We can upload zip files. We can upload image files, and this is what we are going to do. Here I'm using a local image here, which is part of the Mathematica installation. It's an example image. I can use the import command, and this gives me the picture as a picture representation in the Wolfram language. And again, I can now use cloud export with this pic data and say, please export this picture as a PNG and name it lena.png. This again returns a cloud object, and if I get information about this cloud object, you see that it's actually a file, an image PNG file, which is stored under this name here in the cloud. And using cloud import, I can get back this image to my local session here. And once you have put expressions or data in the cloud, you may want to run computations on this data in the cloud. And for these things, the Wolfram language has added a function called cloud evaluate. Here again, let's just connect to the cloud. Here, if I run this function $machine name and $operating system on my local machine, you see this is my local machine. It's always 10 machine, which is called for hour. And using cloud evaluate, I can run the same code, but now on a machine in the cloud. And here, if I run this code here, you see that the machine name now is some PC located in the cloud, usually in Champaign, in Illinois. And the operating system is actually Linux here. And if I re-evaluate this cloud evaluate, it may return a different machine. For example, if I use cloud evaluate to show the process ID of the kernel process, and I do this 10 times, you'll see that all these process IDs are different, which means that every time I evaluate this expression, actually a different kernel process runs my code. And this means for the consequence of this is that cloud evaluations are stateless. Unlike my local mathematization, where Mathematica keeps context information which contains symbol transformations and and other stuff. This is not true for the cloud. When I run, for example, here cloud evaluate and set the variable foo to 100, and then I want to use a table and use this variable again, you're going to see that it doesn't work. And why doesn't it work? Because this symbol exists in only temporary, while the expression is being evaluated, and it is erased once the evaluation is done. If I want the symbol to persist over different evaluations, I have to use a feature called cloud symbol, where I can set a cloud symbol to the name to a certain expression, and I can then use the cloud symbol here to use it in a different computation. And here you see that this works as expected now, and these cloud symbols gives a way to work with symbols in the cloud. This also works for functions. For functions, for example, if I have a function here, actually, and I want to run this function here in the cloud, I have to add the option include definitions true, which will send both the function definition and the arguments to the cloud for evaluation, and then return the result. One restriction of the cloud is that it does not support running arbitrary executables. For example, on my local machine, I can use run process to simply list the contents of my home directory here, as you see. And if I try the same thing in the cloud, it fails. And the reason for that is that there are some restrictions to running code in the cloud. And there's the very important mathematical function Wolfram Language data run process, which gives you information about the actual cloud support status of certain functions. And here, for example, I learned that this run process function is restricted in the public cloud. If I had a private cloud installation, I would actually be able to use this function, because there these restrictions are lifted. How do you run computations in the Wolfram Cloud? Mathematica has the concept of a so-called pure function, which is a nameless function which has some parameters and then runs some code on these parameters. Like, for example, here I define a function which simply produces the greatest common divisor of its arguments. If I run the function locally, for example, here, you see that it's incredibly fast. It's usually less than just a few it takes just a few microseconds to return a result. And there's a similar concept on the cloud, which is called cloud function. A cloud function is a pure function which is wrapped with cloud functions and will be then available to be run in the cloud. This returns the cloud functions, and if I run this cloud function, then using the same similar arguments as here, you see that this takes much longer for each invocation, usually much longer. The reason for that is very simple. Each function call will actually make a round trip to the machine on the internet, then transport all the arguments. It will be run, then the result has to be wrapped up and sent back to my Mathematica session, where I can then retrieve the result. So so it doesn't make sense to run. It usually only makes sense to run complex function in the cloud, where the overhead of this round trip can be taken into account, and takes much, and the actual computation takes much more time. Once you have finished your working on your project, you want to deploy your Wolfram language code so that it is available to different users. And you can do this with the function cloud deploy. And let's, for example, say we want to create a web page which simply prints the current date. In Mathematica, there's a nice function called datestring, which outputs the date and the time. And I can publish this function to the cloud. And this cloud function, I do this with the cloud deploy function. here I'm using the same function here again, and here I'm using delayed, and this delayed here guarantees that the function will actually be evaluated each time somebody then makes use of this deployed function. I set the permissions here to public so that each internet user has access to this code. I'm going to copy the hyperlink now, and I'm paste it into the chat. So let's just say copy address. It's better. And if you go to the chat, you can then click the URL here, and each time you click the URL, you'll see that it actually outputs the date. And if I refresh my browser, it will then reprint the date and time. I can learn about, if it's interesting to inspect the information about this deployed cloud object. You see here that here I have permissions, and in these permissions here I see that all users have the right to execute this code, and I as an owner have to of this code have the rights to read, write, and execute this deployed mathematical expression. Once I'm done with the development, I want to unpublish it from my actual Wolfram Cloud account, I can simply set the options to private here. And if I look at the information again, you see that now the execute right for all users is gone, and I'm now and I'm the only person who is allowed to work with this object again. But the Wolfram Cloud allows you also to deploy more complex things. One complex thing is, for example, a manipulate. Here I've prepared a manipulate, which is a mathematical form of an interactive graphics. And this manipulate here is simply a small Monte Carlo simulation based on Brownian motion, where I can create, for example, can blow up the volatility here. This creates some Brownian motion paths here. I can add a drift here to point it to a certain direction. I can increase the number of paths here, and I can increase the path lengths. And for example, I can change the time step in my Monte Carlo simulation. If I want to publish this manipulator, I simply have to connect to the cloud again, and again I use the cloud deploy function again. And here the Brownian was assigned here. The Brownian makes up the whole manipulate, and here I'm simply deploying the Brownian Monte Carlo simulation to the cloud. This again returns the URL, and again I'm going to copy this to the chat if anyone is interested in. And here I'm going now. I'm going to open this manipulate now in the browser. And here you see it creates a similar interface to what we see in the notebook. I can, for example, here blow up the volatility again. I can add a drift, and I get a path length and a number of paths. And you see this, just compare this with what I find amazing about this is that just with a few lines of code, you can really very easily publish very complex applications to a website, and these complex applications will then be immediately usable to other users. And there are many technologies where this is possible, and where you can do this with so little effort compared to how you can do this in the Wolfram language. And again, if I look up the information here, you see that this tells me again that it's actually all users have the right to read and interact with this graphics. And another interesting feature about this published notebook is, as a user, you can make, if you are an existing, if you have a Wolfram account yourself, you can use the make your own copy button to copy this manipulate to your own Mathematica session in the Wolfram Cloud, and you can then make changes to the underlying code. You can even download it as a notebook here, which is also a nice feature. Once you're done with publishing this manipulate, you can use the set options in permission private to unpublish the manipulate again. Finally, we have the ability to deploy Wolfram Language code as an API function, and this API function is then available as a REST compatible JSON function, which can be easily integrated in other web applications. For example, Mathematica has the very nice ability to classify the language of some text. Here it has correctly classified this text here as German. In order to do that, I have to create an API function, and this API function simply has a text parameter. And then using this text parameter, it runs the classify function, and this gives me the API function. I can use this API function in my local Mathematica session here to run it again here, or here on some Spanish text. And again, I can publish this API directly to the web using Cloud Deploy. This again gives me a URL. And if I copy this address, I'm going to paste it again here in the chat. And if I open this thing in the browser here, you see that actually it immediately returns an error message. And why is this the case? Because this is actually intended to be a REST API which is intended to be consumed by a web service. And I can simply do that, for example, by using the curl command on my, let's just say my terminal here. I say curl and I submit the text I don't know. And here I again have to copy the URL. I'm going to paste it. And you see that the curl command now submits this as an web form to this URL where Mathematica then runs the classify language code and returns the correct result here. And this makes it super simple, for example, to create some Mathematica code, deploy it as an API function, and then integrate this API function in, for example, in a complex Angular JavaScript app or something like this. And Mathematica even supports you in creating the code which consumes this image, this service. For example, here I'm using the embed code functions. I can create code for example, in the programming language Java, which uses the native Java API in order to communicate with this function over the web. And Mathematica can actually create this code for many different environments, like, for example, important languages like JavaScript, Python, or C# are immediately supported. That means even integrating or creating the code to call this API is done by Mathematica for you. And once you are done with exporting the API, just run the set options and set the permissions to private again. Okay, let's just finally talk about the Wolfram Cloud upsides and downsides. I already mentioned it. One huge advantage of the cloud is that there are no local software installations and updates required. This is for if you have a complex environment, for example, in a company where you might have to run out software in dozens of machines. This is a huge step forward in maintenance cost. Another drawback is that, of course, that the browser interface is not as feature-rich as the desktop interface. And here, the problem is simply that the Wolfram Cloud is restricted what browser technology can do. But since browser technology advances very fast, in the future we will have I'm sure that we'll have an interface which will completely match the feature set of the desktop. On the cloud, there exist some limits which are tied to your actual subscription plan. For example, there's a cloud storage limit of 15 gigabytes for the basic plan, and the maximum file sets that you can store there is 1 gigabytes. There's a computation line limit of 10 minutes. That means if a computation takes more than 10 minutes, it will be automatically aborted on the cloud. And there's also a session main memory limit of 2 gigs per session. That means if you have a very huge mathematical computations, you are better off running it on your local machines where you can use the whole main memory which is available on the machine. One important restrictions of the basic cloud plan, which is free for every user, is that the files you upload to the cloud will expire after 16 days of creation, because Wolfram simply has the storage capabilities to keep these files forever. There are also some Wolfram language features which are not yet supported in the cloud, for example, parallel computation using the parallel computation toolkit, which means launching local compute kernels isn't possible. You can do GPU computations with CUDA-Link or OpenCL-Link. You cannot run Wolfram language code, like, for example, code written in C++ or Java-Link. But what's doable is you can use the function compile feature of Mathematica to create compiled code from Mathematica Wolfram language code, which runs then natively on the remote cloud machine. And if you want to access data which is not stored in the Wolfram Cloud, like so, for example, you have some private database, you can not, which is behind some firewalls in your company. There is no way to access this data through the Wolfram Cloud can only access data which is actually stored in the Wolfram Cloud file system. Finally, there are some products which are different cloud. Wolfram offers different cloud products. The first one is Mathematica Online. Mathematica Online addresses the needs of existing Mathematica users. It can be purchased as an extension of a Mathematica desktop installation, and it's available with Mathematica Premier Service Plus, where you can simply Mathematica Premier Service Plus here. If you subscribe to this plan, you have actually both Mathematica Desktop and Mathematica Online then on your service. Then there's a new product called Wolfram One. Wolfram One is intended for newcomers to the Wolfram language. It's a completely revamped Wolfram language experience, which has been designed as a cloud desktop hybrid from the very beginning. If you want to learn about it here, use this URL here. And finally, for companies, there is the possibility to do an on-premise installation of the Wolfram Cloud, which is called the Wolfram Enterprise Private Cloud. This is a Wolfram Cloud which is installed at your local site. It means it runs on your own hardware. It's completely disconnected from can be completely disconnected from the internet. If you purchase this Wolfram Enterprise Cloud, it's usually deployed as a virtual machine image. But Wolfram has announced that now they are in the process of revamping this deployment as a so-called Kubernetes Helm chart and container images. And this will then make it possible to deploy the Wolfram Enterprise Private Cloud also in cloud providers like, for example, Google Cloud or Amazon Cloud or Microsoft Azure Cloud. If you want to learn more about the Enterprise Private Cloud, go to this URL here, which gives you all the information you need. And finally, for the cloud, there's the Wolfram Cloud app, which you can use on your mobile phone. It supports both iOS and Android, and it can actually be downloaded from both stores. And it's actually since there's no native app for Mathematica for your mobile phone, this is the closest thing you can get by using this Wolfram Cloud app, which gives you a similar interface to Mathematica, but on your mobile phone. Yes, this completes this seminar. And are there any questions? If you have questions, please post them in the chat or just ask them now.